Hello viewers, I'm Kausalya. Today we are going to discuss about theorem 6.2 in chapter 6 triangles. So here the statement is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So here the thing is, there is a line that divides the triangle in the same ratio. That is, you see, let ABC be our triangle, right? Let DE be the line. This line divides the sides. Sides means here one side is AB and the other side is AC in the same ratio. What do you mean by same ratio? For example, if the length of AD be 2 and this DB be 4, right? And here let the length of AA be 3 and the length of EC be 6. So now when you take the ratio of sides, that is AD by DB, right? What is AD? AD is 2 and DB is 4. And what is AE? AE is 3 and this EC is 6. When you cancel, you see 2 and 4, your answer is 1 by 2. Again, when you cancel 3 and 6, you get 1 by 2, right? This is known as same ratio, right? Now, if a line divides any two sides of a triangle in the same ratio, then this line is parallel to the third side, right? Am I making what the concept is, right? So, now, you see we have to prove that DE is parallel to BC. Okay, that is what the statement says. So, now we are assuming that DE is not parallel to BC, right? Then, DE is just a line that divides the side AB at D and this AC at E, right? So, it divides in the same ratio, that is the thing. So, when you take the ratio, again you see AD by DB is equal to AE by EC, right? So, now we have to prove that DE is parallel to BC, right? This line is parallel to this line. So in order to prove that, you see here I am drawing an additional line, you see, from the point D, and the line is DE dash. You see, this is the line DE dash that is drawn from the point D, right? And this DE dash is parallel to BC. So here you see DE dash is parallel to BC, right? Now here I am going to apply my basic proportionality theorem, right? So when you apply this, you see when two sides, that is, you see when one line is parallel to one side of the triangle, then the ratio of the other two sides are equal, right? So AD by DB is equal to AE dash by E dash C, right? Now the next thing is from our original diagram, right? This is my DE dash and you see this is my original part. DE is the line. So here this line divides the sides in equal ratio. This is clearly given in the statement, right? That is AD by DB is equal to AE by EC, right? This is already given. Now you see here when you compare the left hand side, the left hand side terms are equal. So obviously we can make the right hand side terms equal, right? So here it is AE dash by E dash C is equal to AE by EC, right? So now we are adding 1 on both the sides. So when I add 1 on both the sides, you see here AE dash by E dash C plus 1 and here AE by EC plus 1. The next step is we are going to take LCM. So AE dash plus E dash C divided by E dash C, which is equal to AE plus EC by EC. Right. So again when you look at the diagram, you see, let me draw the triangle. So this is A, B, C and this is my D and E dash and this is the point E, right? So you see AE dash plus E dash C, that is AE dash plus E dash C. This is nothing but AC, right? So AC by the denominator is E dash C. Now AE plus EC. So this is AE plus EC. What is this AE plus EC? Again it is equal to AC. Right, so AC by EC. So here again the common terms get cancelled, right? We are cancelling AC and the remaining terms are 1 by E dash C is equal to 1 by EC. So when you take the reciprocal, it is clear, right? E dash C is equal to EC. So what do you mean by that? Again, when you look at the diagram here, you see it is clearly given E dash C is equal to EC. That is, both E and E dash are almost the same points. Okay, this is what it indirectly means. So here you see points E and E dash, they coincide. Right. So when they coincide, obviously what happens here, you see this DE is equal to DE dash. Right, they are equal. So finally, we can conclude that DE dash is parallel to BC. Okay, this is clear, right? This is what we already considered. That is DE dash. Okay, this is my DE dash. This is parallel to BC. But now you see this E dash and E points are the same. Or in other words, E dash and E points coincide. They are located at the same point. So if this is the case, then you see what happens. DE dash is parallel to BC. This is the thing which we already considered. Now both the points are same. So obviously we came to a conclusion, right, that DE is parallel to BC, and this is what we need to prove here. Right? So let me tell in simple words. This theorem, in other words, it is known as Converse of Basic Proportionality Theorem. So, what is the basic proportionality theorem? That the thing is, this line is parallel to this line. You have to prove the ratios are same, right? But here in this theorem, this is the converse of basic proportionality theorem. What do you mean by converse here? Here, that is the ratios of the sides are equal. Here we have to prove that DE is parallel to BC. Right, that is the case. So here both the theorems are conveying the same thing with a little difference. Right, in our basic proportionality theorem, this line is parallel to this line. We have to prove that the ratios of the sides are equal. But here the ratios of the sides are equal, and here we have to prove that this line is parallel to this line. Right. So that's all in this video. If you have any doubt, let me know in the comment section. Thank you.